Welcome to a special edition of ENSCO INSIGHTS, live from Space Week in Orlando, Florida. Join us as we explore the latest advancements in space technology alongside industry leaders and innovators at SpaceCom and Space Congress, including breakthroughs in spaceports, launch vehicles, and space mobility. Hi, I'm your host, Brooke Brown. For many years, NASA, ESA, and commercial companies have been trying to develop a single stage-to-orbit launch vehicle. None of these programs so far have been successful. Some of the canceled single stage-to-orbit, or SSTOs, include a variety of spaceplanes and rockets, such as NASA's X-33, or VentureStar, a European spaceplane, British Aerospace HOTOL, the Soviet Mikoyan Spiral, and even Rockwell's X-30 program. Most of these cancellations were due to technical challenges associated with achieving SSTO capability, and the last of these development programs ended in the early 2000s. Today, there is one company that is back in the SSTO business, and to tell us more about it is Neil Lachman, CEO of Titan Industries. Neil has over 35 years of business experience, including 30 years in investing, finance, telecom, and tech. Currently, he leads Titan Space Industries as the founding CEO and chief of spacecraft design. At Titans, Neil has assembled a highly successful team that shares his long-term goals, building a culture of trust and integrity while pioneering disruptive projects to create incredible value for humanity. Neil is recognized for his expertise in orbital infrastructure and his extensive network of space and aerospace experts. Welcome, Neil.
Thank you.
Thanks for being with us today.
Thanks for inviting me.
Explain the genesis of the Titan Space Plan and why it will be a new paradigm in space travel.
Yes, thank you. So the only way to reach space at the moment today is with rockets. And rockets have some certain limitations. First of all, the law of physics. But and as you introduced, there have been some plans, some projects, some trials. What we do differently is we take an old concept. It was developed by Rockwell International, the same people who developed and built the NASA Space Shuttle Spaceplane orbiter. So they were asked by NASA and the U.S. government in the 70s to develop a spaceplane. They came up with the Star-Raker concept. Now, long story short, 40 years later, why and how, but we took that plan out of the freezer and we have improved on it with 40 years of advancements in engineering, materials, computation, computing, and all kinds of technological developments that we can benefit from. Now, 40 years ago, these guys at Rockwell, the geniuses, were already convinced that they could build it. So it's not a real revolution, but it's now an evolution of what we have today, rockets, including plans for ultra-heavy lift rockets like Starship. But those are based on 20th century technology. As a matter of fact, 11th century technology with the Chinese, it's still a ballistic missile, kind of, right, with controlled explosions. What we think we can do better is, well, we don't think, we know, is that we can build a multi-vehicle cislunar transportation system that goes from Earth's surface, from a runway, horizontal takeoff and landing spaceplane that goes single stage to orbit. And then there are other vehicles that will take you to the moon and the surface and the lunar base. So we're the company that says we're going to build everything from the spaceplane all the way to the lunar surface, a lunar base.
Mm. Leads me to my next question. Can you tell us a little bit more about the unique features and key technological advancements the Titan spaceplane will have that make it different from the original Rockwell Star-Raker design?
Well, I have to be honest here. We benefit from their uh, uh, design, from their concept, including the analysis. As a matter of fact, we pride ourselves in copying them and borrowing from them. So we don't really change much, we improve. And it has to do with the advancements of the last decades um, in terms of engines, for example. Today's engines are more powerful and have more thrust than they could have 40 years ago. Materials, right? You can build the same space plane that they were planning 40 years ago with lighter materials, for example. Partly, we still use aluminum, but for example, cryogenic tanks, for hydrogen. That has been a huge issue with even a few of those vehicles that you mentioned. Now you can improve on old concepts and still benefit from the genius know-how that they had 40 years ago. So we improve on things. We don't change much. The only major thing that we did is that we said, instead of only cargo, because that was the plan, to haul mass every day, 3 times a day per plane, years on end, rapid reusability 3 times a day. The only difference we have is that we said, instead of only cargo, we can also make this a space tourism vehicle.
So that leads me to my next question. What are the primary missions and applications for the Titan spaceplane beyond space tourism?
So space tourism is very important. We think we can scale it up to a multi-$10 billion revenue per year. Space tourism alone. LEO with the spaceplane. Spaceplane will only go to LEO, right? Low Earth orbit, and not beyond. So space tourism is very important, but this vehicle is a multi-purpose vehicle. So the payload bay, which is huge, 6 meters by 6 meters, and 45 meters long. It's huge, larger, bigger than Boeing 747's fuselage. You can we'll take out the passenger module, and then it becomes a cargo module. So it's a removable module. Then you can use it for huge mass to orbit missions. So we like to say the fact, and this is really shocking, we can do in 1 week, once we become operational with this spaceplane, we can launch in 1 week to orbit what the entire rocket industry will do in 1 or 1.5 years. It's such a scale. It's exponentially more powerful in terms of operations.
Very impressive.
And then, of course, to continue, we also have capabilities for, so space launch is one thing, space tourism, space launch is one thing, but for defense, for example, military application, transporting personnel, 350 people per flight within 45 to 90 minutes suborbital, it's a huge point-to-point vehicle also that can go suborbital in a ballistic arc. So the transportation time of cargo and personnel can be, maximum 90 minutes from one point to the other side of the world within 90 minutes.
Very impressive. How does the single stage to orbit, or SSTO, capability enhance the efficiency and cost effectiveness of space travel?
So, talking about our single stage to orbit, it's the scale. So we're not promising that we'll do $100 tickets. We're also not promising to do 10, 20,000 people per day. But we could, because of the costs of the operation, which is still exponentially lower than rockets, but it's about the scale. So you can do a lot of missions, many missions, quickly compared to any other transportation system. So that makes it very efficient. The rapid reusability, we don't say 3 times a day like Star-Raker was planning. We say once a day for one particular mission, and the other day then for another particular mission, for example, Space Launch. But it's all about the scale. The Spaceplane is such a huge vehicle that, as I said, we can do in 1 week what the entire vertical launch rocket industry can do in 1.5 years. So it's all about the scale. We don't need to charge customers for space launch of satellites or anything, even beyond LEO. We will use the Spaceplane as a first stage, where the second stage or the payload will be ejected out of the payload bay into space, and then it continues its trajectory to the moon, for example, or Mars, even if it's, for example, a satellite, a spacecraft. So yeah, it's about the scale. It's about the rapid reusability and the price. We don't need to charge tens of millions per customer. We talk about millions instead of tens of millions. And we can do ride share, just what Falcon 9 is doing, SpaceX is doing with Falcon 9, ride share and everything. That's what we can do for everybody. So, you're talking about $1 million per mission, even. Not our mission, but I mean for the customers. So instead of them paying $5 million for launching something into orbit, for example, we can do it for much less.
How does the horizontal takeoff and landing, or the HTHL feature, contribute to the safety and reusability of the spaceplane?
Wow, beautiful question. Very important. So this is really a huge differentiator, and it's going to disrupt the entire space industry. The genius of the Rockwell designers, Star-Raker concept designers, was that they said no rocket, no magic involved. So they will use modified, off-the-shelf jet engines for sea level. So on a runway, we'll take off like a airplane. It's as simple as that. And that's the beauty of it. Then when you want to go to space, you ignite your rocket engines. So that's another anthem. And then the third engine system is when you are already in space and need maneuvering. Then you have the OMS, the orbital maneuvering system engines. So Rockwell designed those 3 engine systems, and it's just practical. There's no magic involved. So it makes it an aircraft-like operation. So you don't think twice before flying with an airplane. This is the same thing. There's no vertical rocket launch. There's no explosive explosions, controlled explosions needed, for example, for stage separation. So the engine systems, the fact that it goes into air like an airplane, the single stage to orbit nature of the spaceplane makes it a hugely safe and efficient vehicle.
What are the environmental impacts of the Titan spaceplane, and how does it address sustainability concerns?
Wow, I didn't expect that one, but that's a good one. You're full of good questions. Thank you. So there is this whole change now in the industry with sustainable air fuel, aviation fuel, SAF. So that's something that the industry is doing already and will follow the industry. So instead of environmentally unfriendly fuels, you can do SAF. That's one thing. Then the second thing is hydrogen is a non-pollutant fuel. So the only exhaust is water, vapor. So it's a hugely environmental friendly vehicle. So yes, there are 10 jet engines, 5 on each side, and then 3 1 million lift force rocket engines. But there is no big environmental impact with SAF, and that's something that is mandated by the world, by people, environmental agencies. SAF is going to happen one way or the other on a large scale. So 3-4 years from now, before we start flying, this will be a major industry in itself, SAF.
You had mentioned this a little bit earlier, but I'll refer back to when I was looking at your website, I saw Titans also has an orbital loop program and Earth loop program.
Yes.
What can you tell us about these loops?
So Earth loop is our 5-hour program. We call it an orbital cruise. So you'll go with a space plane into orbit, 300 kilometers altitude, and you'll be in weightlessness in 0G. You'll be weightless for 3 hours. As a space traveler, space tourist, you'll have 3 hours of weightlessness in 0G. And that's an amazing experience. So this goes beyond what Virgin Galactic can do with their spaceplane rides, which is a 2-stage to orbit, as a matter of fact. Not even orbit, it's suborbital. And Blue Origin with their suborbital flights. So their experience is 4 or 5 minutes max in 0G. With us, you have 2 orbits of the planet, 3 hours of weightlessness. You'll see 2 sunrises and 2 sunsets. So it's a completely different experience. It starts at $395,000 per person, I think. Then there is orbital loop, which is a space station kind of experience, and it will keep you in orbit for 3 days. So the Earth loop, the 5-hour program, is for a lot of people. We put up to 350 people per flight in special space spots inside the spaceplane. The orbital loop, the space station experience kind, is for 3 days whereof 2.5 days in 0G, in weightless mode. And it is in special cabins. We call it an orbital super yacht experience. So you won't be there with hundreds of people. You'll be there in a special cabin for 2 people, and we'll have only 24 to 30 people on board. and it's expensive. It's going to cost $12.5 million dollars per person. In the beginning, we'll only do couples or duos. So we'll only sell per two persons because of a cabin. But that's an amazing experience. We'll have a third one, which is the space station itself. That's the Leo Space Hotel, what we call it, and that will be a 3 to 5, maybe 7 day stays in a real space station. But the space plane orbital loop super yacht experience it's going to be really amazing. Yeah.
We need to take a short break, but when we come back, we will continue talking with Neil Lachman of Titans Industries. He will give us some insights for what orbital space planes will be.
Long before liftoff and beyond, one team has set our trajectory for assured access to space.
Engines throttling up.
By taking ideas
Go and throttle up.
to reality. We are ENSCO, Aerospace Engineering.
Welcome back to this special edition of ENSCO Insights. We're talking with Neil Lachman of Titan Industries about their space planes. How does Titan Space Industries plan to scale operations and ensure economic viability for commercial and humanitarian missions?
So, yeah, that's the most important thing. A lot of companies go bankrupt because they haven't figured that out. So we specialize in this. We have a co-founding team. So I'm not the only founder. We have a big group of co-founders, and I love to have many people around with me. Most of them I've worked with for 10, 15, 20 years in other projects and so on. But economic feasibility, revenues, and so on are very important for us. So we have figured that out. That's a bit of a business secret, but yes, the next few years, we will be focusing on ultra high net worth individuals called Titans astronauts. They get unlimited space access on a fair use policy, but they pay us $25 million. We think we have the ability to get 1,000 of them. 1,000 times 25 million is 25 billion. So you'll be good anyway. We're not saying we will have and we need 1,000 of them, but that's one avenue for us to get revenue in the next few years before we start the flights. So they get their training and so on. So that's one thing. We can start pre-selling launches and so on. So there is a whole list of opportunities that we can pursue in the next few years before operations.
So you really think there are enough customers for Titan's spaceplane?
Yes, so 25 million per person is a lot of money, of course, but there is a huge number of ultra high net worth individuals. We're talking about hundreds of thousands of people. So if it were, that we are a real estate developer, then yeah, that would be a very competitive market. But for this experience, something for yourself, not for your employees, not for your shareholders, not for your partner or your children, but for yourself. This is a unique experience. It's unlimited access to space. So we'll take you as often as you want and as often as we can accommodate you and other customers. But yeah, we think there is a market of 10, 15,000 people that can do this with us. So we still want to be, we aim high to 1,000 people. But, if there are only 100 people, we'll be okay. I know a lot of people myself. And for example, we hired Chris Dombrowski, the Inspiration 4 astronaut. He is our chief astronaut, and he's our chief trainer. He'll train these people over the next few years at the Titan Space Academy. So yes, there is a huge market. 1,000 people sounds like a lot. 25 million per person sounds like a lot. But if you can't afford it, we won't talk anyway. So this is about something personal. For a lot of people, space travel is something beyond their dreams. We also say, our tagline says, going beyond imagination, which was, by the way, by Rutger Hauer, the original Roy Batty cyborg in Blade Runner, good friend of mine, passed away 5 years ago. But yeah, so this is the future of space travel. We give it an tourism, space exploration a twist, but this is something that people will want for themselves.
This all sounds really good. What will the first flights carry, and who will fly in your first flights?
Wow. Yeah, so Chris Zembrowski, our chief astronaut, is working now. So we told him he has the liberty to invite people, especially former astronauts like himself, to fly with us on the inaugural flight, which we want to do either late 28 or early 2029. So there will be people going with us on the inaugural flight, but we have 350 seats available. So that will be a commercial operational flight. Those flights before that will already be tested. So the Spaceplane will be tested. It will have to be certified by the FAA or whatever space agency in charge by then. But it will be a safe vehicle then, certified by the authorities. And I'll be on the test flights anyway. But yeah, the inaugural flight will take up to 350 people, and then a crew of 10, 12 people for the Earth loop, 3-hour weightless. Yeah. What?
We need to wrap this up, but what would I need to do if I wanted to book a flight with Titans?
Wow. So we'll start. So behind the scenes, we have been working already with a lot of potential astronauts, civilian astronauts. But we'll open up officially in February, in a few weeks from now, 2 weeks, let's say. And then you can go to our website, titanspace.com, and you can then see the options. Get in touch with us through a form or connect with us on LinkedIn. We have a large team present on LinkedIn. And yeah, get in touch with us and we'll get it from there.
We look forward to seeing your first launch, and thank you, Neil, for joining us here at SpaceCom.
Thank you, Brooke.
Thanks for watching this special edition of ENSCO Insights. Be sure to stay connected to the Space Intel Report for the latest updates on the space industry. And check back here for the next episode of ENSCO Insights as we continue to probe the fascinating world of space exploration and technology. I'm Brooke Brown. See you next time.